Where are we? So the next practice that you can do is the next slide. Which is this one. Yes. Yeah, so this is very nice table. Okay, so you put P equal 1. And then you calculate the future value, okay, based on different time and different compound interest. Okay. And you make this table. Yeah. You can compute that easily. Okay. So 1 plus K over 100, right? And then exponent of the n. And then you just copy all. And then you do a conditional formatting. Okay. So once you make it, do you understand the meaning of this table? And you explain the meaning of this table. What is the meaning of 1 there?
That is the present value right now.
Yes, but for example, after 10% and 0n, you still put 1 in here, right?
Yes, because the time is still 0. It's still right now.
Right now. And how about this? The time is 10 years and 0 interest, you still pay 1 in here. So if there is no interest rate, okay, whatever you borrow, you return again at the same value. Okay, there is no inflation. Okay. So what you put there in the present value will be exactly the same as the future value, 1, right? But what happened is, because of the interest rate or because of inflation, say your inflation is 5%, right? So after a certain number of years, then your value will become increase, can be double, triple, 4 times, and so on. And if you borrow from a credit card company, say you are using credit card, how much is the interest per month? More or less. If you borrow from the credit card company, how much is the interest per month? Do you know?
I'm not sure. Wait.
Okay, check. Check in Google.
The current rate is average 2.95%.
Yes, about 3% per month.
Yes.
That means per year is multiplied by 12. How much?
That is 36%.
Yeah, about 36%. Okay, so if 36% and you borrow a very long time, okay, so you look at the value there. Instead of 1, for example, if you borrow 30 years at that rate, you will pay around 10,000 times of your principal. So if you borrow 1, you will pay 10,000. If you borrow 10, you will pay 100,000, right? And so on. So the percentage is look like less than 1, right? It's only 36%. Okay, but the real value that you need to pay is more than double, more than triple. Okay, and at certain rate, for example, like 36%, okay, it's like in 5 years you need to pay around almost 5 times of your the one that you borrow, right? So this is the value 4.65 for 5 years. That means around 5 times the one that you borrow. So you should be very careful when you borrow from the credit card company. Okay, so that table will give you the amount, how many times, okay, the principal plus the interest that you need to pay back if you borrow 1. Okay, so this table is very important. Okay, so let's go to the concept of equivalent. So when you compare 2 cash flow, you must compare based on the characteristic of the same basis. Okay, so say 2 cash flow are equivalent if the interest rate K at certain interest rate K, if we can convert one cash flow into another using the proper compound interest factor. For example, if you have a 10,000 deposit for 3 years at 8%, okay, the value will be $12,596. Okay, at 8%, what's the meaning? At 8%, the $10,000 at time 0 is equivalent to the 12,597 at times 3. Okay, so the two values, 10,000 and 12,597, they are actually the same value. When we say equivalent, that means they are actually the same value. Okay. The difference is the time and the interest rate. So okay, so if you take a 1 million loan, say this is in US dollar. No? If you take 1 million loan to buy your house, the interest rate is 10%. Okay, so how much is your total loan equivalent you need to pay for each option for 5 years, 10 years, and 15 years? So you already have it a while ago.
This is why, yeah, just use the future
table that
value.
Yes, just use the future value. Okay. You're supposed to get this value, is that correct? From your table, the one that you just make, the two tables.
Yes, it's 4.18 there.
15 years, 4.1.
Yes.
Yes, right? So from the table, you a while ago, you can already get this value. Okay. Now, say you are creating a software. Okay. This is the potential cash flow per year, per annum, for selling your software. So in the first year and second year, you get 1.5%, and then you will pay 20,000. And then in the second year until fifth year, you pay 1.75%. The interest rate is 1.75. It is the growth. And then you get 15,000. So now, can you convert its flow to the year 0? And then can you calculate the present value? Can you calculate the present value? So knowing the future value, can you calculate the present value?
Yes, knowing the future value, we can over the present value using PV.
Okay, so then you put everything back to the present value. Okay, and when you can get back the present value, you're supposed to get this is the value that you put there. Okay, let's do it in a new table. How much is your value a while ago? Okay, let me share the screen. Right, so you have a year 0, 1, 2, 3, 4, 5. Is that correct? And then your in cost and your income. Okay. In year 0, you don't have any. So in year 1, you pay 20,000. And then in year 2, you get this one plus 1.5 divided by 100 multiplied by this one. So this is your cost. From year 2, you get also 15,000. But after that, you increase. Okay, you increase this one plus, how much is that? 1.75. This is your growth, right? Divided by 100 multiplied by earlier. 2 to 5. Okay. Then you need to get the PV. Okay. So this is the cost, PV, and present value of cost. And then you get the present value of income. Then you get the present value net. So how do you get the present value of cost? So you get the, go to the table a while ago. Right? So if I know the future value, I want to get the present value. So you will get minus PV. Right? So that one is minus PV of what? The K. Oh, the K should be changing here. Let me put the K here. Insert column. So the K is changing. How much is the K here? 1 point. How much? 1.5. 1.5. And then here the K is 1.75. So there, minus PV of the K divided by 100. N is this one, 0, comma the F. Okay. How about this one? This one is the same thing. Eh? So minus PV of the K divided by 100, comma the N, comma 0, comma the income. Income is here. So the one that I don't need to change to copy down. PV net is income minus the cost. So B will not change, C will not change. Okay, then I can copy down. You're correct. Can you see it? Is this correct or not? Then you start to get what is called MPV. MPV is this sum. I need to get this sum here. Let me get. So this is the NPV. You need to get the PCR and then you need to get the IRR. How about the PCR? PCR is the benefit, this one divided by the cost. Okay. The IRR is IRR of these values. There you get 23%. So if you have a project like this, okay, this is your cost at different interest rate, right? And how do you compare, right? Different income, different costs at different interest rates. So how do you compare? The compare is the way to make comparison is to put everything in the present value. This is the year zero. Okay, to put it in the year zero. And then after that, you compare using this three performance index. Yeah? So if NPV is larger than zero, that means you have profit. Okay? If your NPV is actually less than zero, that means it's negative. If PCR is larger than one, okay, you get profit. Of course, the larger is better. Okay, so probably the most important part is the IRR. Okay. What is this? IRR is like the interest rate of your project. Okay, so the IRR you need to compare with the bank rate. So if you put the if you put your money of your investment in the bank and deposit, say you get 5%, right? So if your IRR is actually less than that, you better do not do anything, right? Put your money in the bank and you sleep. But if your project give you say 23% like this, of course, you better work compared to putting your money in the bank. Because if you put your money in the bank, you get only 5%. But if you do your project of this software, you get 23% per year. You get it? Any question? Are you still there?
Yes, sir. Yes.
Sir, can you show your Excel again?
My Excel again? Okay.
Yeah.
Say you have this cost and you have this income. So this is given, okay? So the one in yellow are given. This one also is given. So you can just type that. So now you want to know if your investment or your project it's actually worth it or not, isn't it? How do you compare? Because now you have different timing, different interest rate, right? Different values. So this is how you compare. Huh? Okay, one project is 5 years, different project is 10 years, for example. How do you compare? Again, you calculate like this. Okay. How do you calculate? You put it back all into the equivalent of say times zero. Okay. So present value of the cost of the income.
Okay, sir. Thank you, sir.
You get it?
Yes.
So NPV is the sum of this. Okay? PCR is the sum of income divided by the cost. Yeah. IRR, there is a formula in Excel. So equal IRR of the net. So of course, in the beginning of your project, usually you lose money. That's why negative, right? And then after that, you start to earn. So the question is whether you are earning in 5 years. And what is the IRR, okay? The internal rate of return. So you compare the NPV with 0. You compare PCR with 1. Okay? That represents profitable or not. But at the same time, I think the best one is actually to compare the IRR. The IRR you not compare with 0, but you compare with the bank rate, okay, of time deposit. Any comment, any question until here? Or are you still doing it?
Yeah, we're still doing it, sir. Yes.
Okay, okay. So,
Interest rate. That's a while ago I got disconnected.
which part?
The compound interest.
The compound interest.
Yes.
The table, you mean?
Yes. How we get that number? Because I've tried, but I got the wrong result.
Okay. Is this the one you mentioned?
Wait, oh yes, that one.
Okay. So the formula is down there, the one in yellow. So future value of the principal, okay, multiplied by 1 plus k exponent n. K is the interest rate, n is the time. In this case, p is equal 1.
Is equal 1. So we calculated using the minus future value, right?
You can, or you can just put into the formula. Let me show you. In Excel, I just use the formula directly. So n and the k, right? And then you just put this formula. So 1 plus the k divided by 100, because this is supposed to be percent. Right? Exponent of the n. N is the one in the left, which is in column A. After that, you copy to on to fill up the table. So this represents how many times you will pay if you borrow money today. Okay. How many times you will need to pay in the future if you borrow money today.
Your P one is the interest rate annually, right?
If you put the value 1 in here, meaning you don't have any interest. So like the first row here is all 1. First column here, all 1. That means if you have no interest, there is no the principal is written as principal. Right? The principal was 1, right? So then you return exactly the same as your principal. Okay. But if your value is like 2 in here, so say 8% at 9 years. Okay, so the value is 2. What does it mean? Meaning if you borrow today, okay, 1, say 1 million, okay, at 8% for 9 years, then you need to pay back after that 9 years, you need to pay back 2 million. So the value 2 here, if you borrow 1 million today, so then you need to pay 2 million, okay, at the 9th year.
Why I got 1,01 for the N5? So your P42, at that one I got 1,01.
P40.
Yeah, that one. Yeah, it's supposed to be 1, right?
Because 0 interest, right?
Wait.
Are you using the same formula?
Yes.
Okay, can you share your screen?
Okay, wait. This one.
That one is C4. Where is C4? Oh, don't do that. The interest supposed to be B34.
B30. Oh, this one.
B34. Okay, and then that one is correct. So now you copy all.
So this one.
No, you copy B35 to all. So you don't change that. You go to B34, okay, 35. Okay, Control C. Control C.
Yes.
Okay, and then use your shift arrow, shift and arrow. Shift key you press. Okay, and then arrow to the right and down. Right there, and then Control V.
It's supposed to be. This one is already.
Right.
Okay, I think it's already correct.
Yes.
Okay.
Okay, good.
Okay, thank you, sir.
Yeah. So, are you okay with that? Do you understand the meaning of equivalent? equivalent cash flow. What is the meaning of equivalent cash flow here? Nivi, Mancha, Joy? What is the meaning of equivalent cash flow? Can you start to explain? Say if you have money today 100, okay, at 1%, next year your money is supposed to be say 1%, that means 101, right? Next year. Or if you have 10%, that means your money is supposed to be 110. So 110 next year and 100 today, okay, they are actually the same value. So the two value at different year, different time interest, they actually have the same value. So this is the concept of equivalent cash flow. You got it? Okay. Two cash flow have the same value at different time, at different interest rate. Okay, when they have the same value, so we call them equivalent. Okay, so let me share this. So suppose your value, the money that you have right now is P, right? And F is the amount of money that you have in the future. K is the interest rate per year, and N is the total number of years that you invested the money. Okay. So if you invest your money for 1 year, how much you get? So F1 is the P plus the interest, right? That means P plus, what is the interest? Interest is P times K. Okay. So in that case, you add, you will get P multiplied by 1 plus K. If you invest for your money for 2 years, what will happen? You get F2 is equal to F1 plus the interest. But the interest depends on F1. So in that case, F1 plus F1 times K. Okay. So, but remember, F1 a while ago was already P1 plus K, right? So then you input that back from, so F1 you replace with P1 plus K. So now you have P1 plus K multiplied by 1 plus K. That's equal to P1 plus K exponent 2. So if you continue this, okay, you will have this formula. So if you invest your money for N years using compounding formula, you will have this formula. Fn, okay, equal to P 1 plus K exponent to N. So graphically, we will put like this. P is the payment that you put down now at time 0. Okay? And then you will receive F in the future when the time is N. Okay? So, okay, let's practice this. Suppose you have a 5% compound interest and your money today is 783.53. How much is your money worth equivalently 5 years from now? Anyone who can answer this quickly, you can claim your recitation point.
Sir, how much is the value again?
The value, so 783.53.
783 point.
783.53, 5% interest, 5 years. Okay, so
So it should be 1,000.
yes. So given P today, right? Then you're supposed to get the future value. It is 1,000. Okay. Livy, Joy, can you get this?
Wait, I'm still calculating.
Now, Pancha, you try to do this practice.
Which one, sir?
Prediction based on inflation.
Sorry? Prediction on inflation.
Based on inflation. So suppose currently you spend on average $2 for each meal in cafeteria, and the government said the inflation rate is 5.5% per year. Based on above information, how much will be the price of the same meal in the same cafeteria 5 years from now?
Okay, so we just use future value then.
So how much is the future value? If your dollar spending for each meal is $2, and then inflation rate said is 5.5.
The present value is how much then?
Present value is $2.
$2. Okay. Oh, it should be. Oh. Is it? Oh, wait. It should be 2.61.
61, right? Now,
Yeah.
now my question to you. This one is given the present value, interest rate, and the number of years, right? So there are 4 variables here, right? P, F, K, N.
Yes.
So what are you given? P, K, N, you get F, correct?
Mm.
So if I know the F and K and N, can you get the P?
Yes, using present value.
Okay, so now if I get the P and F and K, can you get the N?
Yes, using NPR.
If I get the P, F, and N, can you get the K?
I don't know how to get the K.
Now think about it, how to get the K.
Is there an Excel function for it, or we just find it normally?
Okay. Can you take a logarithmic of the 2 of them? The same formula, okay? If you take log for the 2, you will get what?
Get if we log 2, the present value, do you mean?
No, the formula. The formula is this one, right? Okay, can you take the log of this formula, logarithm? So if
What?
left hand side, you're supposed to log the right hand side also,
Yes.
right? And then you can get N in that case. You can also get the K.
Yes. Yeah. Oh, yeah.
Yeah, okay.
Okay.
Mm. You can derive your own formula.
Yes. Okay. Yeah.
So if F divided by P, you will get 1 plus K exponent N, right? So then if you exponent that with 1 over N, both sides, you will get 1 over 1 plus K, correct? I will put in the whiteboard. So you have F equal to P 1 plus K exponent N, correct? Then I will put F divided by P equal to 1 plus K exponent N, right? But now I put both of them, I exponent with 1 over N, and then this one is exponent with 1 over N. What I will get? I will get
1 plus K.
yes, F per P exponent 1 over N equal to 1 plus K. So in that case, K equal what? F over P exponent 1 over N minus 1. So you can
Yes.
get K, yeah. To get N also you take the log. Okay, so to get the K you exponent. Yeah, clear. Yeah? So once you know how to get K and N from future value and present value, you can also calculate the, say, suppose, okay, calculate this. In 1987, I entered Petra, the price of, what is that, pangsit mee is 400 rupiah. 1987. Today, 2021, okay, the same seller, okay, sell that at 30,000. rupiah. So my question to you, based on that model only, how much is the actual inflation rate? Inflation rate of the noodle.
Yes, okay.
Okay. So
Oh, it's really high, 13.5%.
correct.
Yeah.
13% is the actual interest rate, the inflation rate. So
Yes.
what the government report is only 5%. That is not true.
Oh, but it's from like 34 years ago. That's probably what because of 1999.
Probably, yeah.
Yeah.
So now with this, you can start to ask, okay, your parent, okay, simple measure to, of course, this is not just simple. So simple measure, you ask your parent, after 99, for example, or you yourself, okay, of the same vendor, okay, the same seller, how much is the price at that time, and what year, and how much is the price today? Then you can start to calculate the real inflation,
Yes, sir.
okay, of certain things. So is this useful?
Yes, it is.
What the government said, okay? So then you will see the actual interest rate or the inflation rate is much higher. Okay? Because why is that so? Because the government only controls certain products, like the rice, the oil, and so on. Probably not so much changing in this product that controlled the government, but other things are increased much higher. Okay, so if your inflation rate is say 13%, so if your real income is only increased 10% per annum, that means the quality of life is actually reduced. Okay, so this is interesting. So to get back the same formula, if you want to get back the present value, that's super easy. Yeah? You just put it back. The present value is equal to Fn divided by that compound interest. Okay, 1 plus k exponent n. So this formula is useful if you know the future value, okay, and the interest rate and the number of years to get the present value. When is that happening? Say if your uncle give you 1,000 a year from now, promise, okay, assuming 5% return, how much is the present value? Okay, so the present value must be worth less today than the same amount offered. Okay, so the sum of 1,000 offered to the person a year from now should be worth less today than the same amount offered immediately. Okay, so then put it there, you will see that the value should be 952. So worth less today. So this is the formula a while ago that I discussed, that I put in the revision. Okay, so suppose you know the amount of money at present and the future, okay, and you want to know the interest rate. So this is the formula. Okay. So suppose that after 10 years, your $100 investment have grown to 160. Then you ask, how much is the annual return? Anyone can calculate this?
The annual return.
Annual return, meaning the interest rate.
Yeah.
Okay. Annual return is the interest rate. Say you get the price of the house. Okay. 10 years, 10 years before or 5 years ago, and today, how much? Okay, before and now.
It's
You will get,
31%, 32, 31.95.
in this case, 30. No, I got 4.8. How do you get 31?
Oh, hold on. 160 divided by 10, right? 160 divided by... Oh, is it 10 or 100, sir?
100.
Oh, 100. Oh, yeah, yeah. Okay.
10 is the years.
Yes, okay. Yeah, I put 10 for the present
Okay.
value. Yeah, that's why.
Okay.
Yes, 4.8%.
Okay, 4.8%. Okay, so if you just divide by 10, that is 6%. This is not correct. Okay, so you need to use scientific calculator. If you want to use calculator, you need to use scientific calculator. You cannot just use the normal calculator. Until here, can you follow, Livy, Joy?
Yes, sir.
Yes. Is Joy still there?
Yes, sir.
Okay. Yeah, this is the same as a while ago. Okay, so this is, I checked when I was in the Philippines. So this is the price in the meal in the campus cafeteria in 2008 was 45 pesos. That is around $1.5. And then price the same meal in 2012 is 65. Okay. So if we calculate that, what is the inflation rate in this case?
%. Yeah, that's kind of high. 9.6%.
9.6%. Okay. So the government inflation rate in the Philippines said only 5%. So in real value is actually about 10%. I think the same with Indonesia. So I think Indonesia is around 13 to 15% inflation. But the government keep reporting 5%. It's under report. That's normal. Okay. So suppose you have a $10,000 today. It's like 150 million rupiah, right? So at 5% inflation rate, what will be your equivalent value of your money 10 years from now? Say if you have $10,000 today, okay, if you put 5% inflation rate, right, based on the government report, what will be the equivalent value 10 years from now?
16,288.
So how much reduction? No, this is not
Sorry?
no. The inflation rate is 5%, though the value must be less.
This is yeah. Okay.
Okay, the value must be less than 10,000.
Oh yeah, I thought it was like investment. Okay, yeah, not Not dimension. Okay. Yeah.
Okay, so if you put 16,000, that is not correct.
$6,139.
I
Right.
computed 559 in my computation.
Oh. The n is minus 10, right, sir?
N is 10, not
Oh, yes, 10. Oh, wait.
but the interest rate is negative, right?
Yeah, okay. Oh, yeah, 5,980.
So the reduction is like 40%, okay, in 10 years. If you don't do anything with your money, okay, just let it be. Just put in the under your pillow, okay? Because of the inflation 5%, right? So in 10 years, it will reduce 40% of the value. Oh, this is sad, isn't it? This is the sad reality. So, any comments until here? Any question? So, you are living in the world that having interest rate. Okay. Long time ago, the interest rate was banned. So, long time ago, say about 12 centuries or 13 centuries. But now you are living in the different era. Okay. So we have a world of interest rate, but a lot of people still don't understand what is the meaning of interest rate. So then they still think linearly, but the interest rate is actually non-linear. Okay, I hope this lesson helped you on something. Okay. So I want to discuss maybe next meeting about the Rule 72 and so on. Okay, so
Sorry, sir. Rule
72 is the doubling time, doubling money.
Oh, okay.
Okay. So that one for next meeting and so on. Let's conclude today's meeting. Is that correct?
Yes, 10:30. Yes.
So what did you learn today? Tell me.
Oh, well, we learned a lot. We learned about how to find the how to find interest rate and inflation, how to set present value and future value. We have learned about to how to find out if a project is benefitable or not, like from the income and cost. And yeah, we also learned about how to find the interest rate given the present value and future value as well.
Okay, good. So next time we will calculate the N. So given the interest rate, how long this one will be. Okay, so read the slide if you have time for the next meeting so that you can have a better preparation. And thank you for today.
Okay, thank you, sir. See you next week.
Next week.
Okay, thank you, sir.
Mm.
Thank you, sir. See you.